Right, so in E, so we want to show that there's a solution to this expression. Right, so even though I don't give you an equal sign, saying that there's a solution means that this thing should be equal to 0 at some point on this interval. All right, so if I look at this, I'm going to do Bolzano's theorem because Bolzano's theorem is when the function is equal to 0. So our function here would be x e to the sine of x, which is going to be continuous for all real numbers. Right, so sine is continuous for all real numbers, so there's no discontinuities there. E to any number, e to x is going to be continuous for all real numbers. So this e to the sine of x is always going to be continuous, and x is obviously a continuous function as well. All right, so then for Bolzano's theorem, we want to show that f of our left endpoints of our closed interval and f of our right endpoint give us a positive and a negative value, right? We want to bracket 0 between them. So if I did this, I'd get a 3 pi over 2 times e to the sine of 3 pi over 2. So 3 pi over 2, sine of 3 pi over 2 is going to be equal to -1. So we're going to get 3 pi over 2 times e to the -1, which is 3 pi over 2 to the e, or you can plug this into a calculator. This is going to be a, oh, wait, there's a -2. That was like, oh, that's in trouble. Right, there's a -2 over here. Phew, -2. So this should be a negative number. But let's just make sure, right? So I'm going to do a 3 pi over 2e minus 2. So we got a 3 pi divided by 2e. And then, yep, so then we're going to take away 2 and get a negative 0.27. All right, so this is less than 0. All right, so then f of 2 pi, we're going to get a 2 pi e to the sine of 2 pi minus 2. That's important. All right, so we're going to get a 2 pi. Sine of 2 pi is 0, so we're going to e to the 0, so just 1 minus 2. So we're going to get a 2 pi, which is like 6.28 minus 2, so this is greater than 0. And so again, we're just going to now kind of conclude, and we're going to say since our function, which was x e to the sine of x minus 2, is continuous on our closed interval, 3 pi over 2 to 2 pi, and since f of 3 pi over 2 was less than 0, and f of 2 pi was greater than 0, Bolzano's theorem guarantees a solution C such that C is in this interval 3 pi over 2 to 2 pi. And there's our Bolzano's theorem.